All right. Not many people here today yet. Oh well. I suppose it's a little early and it's cold today. All right. We're going to look at photogrammetry a little bit. Now, I'm not an expert in photogrammetry, but I've done it a little bit, used it a few times. So I can at least show you the idea of what photogrammetry is about. We're also going to look at, I did get that Wood PLA in. This one, let's see. Got this one. Best, 3D Best. Came off of Amazon. This one was rosewood. We'll look at that. In order to print the filament, I changed the nozzle out, so we'll look at that also, how you do that, because it's not quite as straightforward as just unscrewing the old nozzle and putting the new nozzle in. There's a few things you need to be aware of, so we'll look at that, and then whatever else I come across at the time, whenever I pick it up or whatever, we'll talk about other things too, but those are the main things. Why don't we start with the photogrammetry stuff? So the idea with photogrammetry is that you have an object that already exists. So there's some physical object in the little preview thumbnail thing. There's a car, part of a Mustang car that I put in there. But you got this object, it already exists, and you want to digitize it so that you can do stuff with it on a computer. So you might want to print it, or maybe you just want to edit it, or maybe if it's a car, you want this geometry so that you can, I don't know, create some aftermarket part for the car, whatever it is. So there's a lot of different ways to do that. One thing you could do is you could, take a bunch of measurements and try and recreate the shape, the geometry. There's the picture I'm talking about. You could create the geometry by taking careful measurements. So that, depending on the object, that might be the right way to do it. Because you could probably get, if you're doing a cube or a rectangle or some pattern of holes, then that's probably a better way to do that. But if it's more organic, compound curve shape, it's going to be tough to get that geometry exactly like what exists in the real world. Another thing you could do there are scanners that are available everywhere from, you can go to GameStop, or not GameStop, Game Exchange. You might could go to GameStop too. You go to Game Exchange or someplace like that and get an old Xbox 360 Connect scanner for $40, whatever they're selling them for these days, and turn that into a scanner. There's open source software. Assuming you're on a Windows machine, I don't know if it would work on a PC, on Apple Macintosh, but it works on Windows machines, and you can use the Xbox scanner as a handheld scanner for geometry. You're not going to get very high resolution, but you'll get kind of the rough shape. They make the same type of scanner. Can't think of the company that makes it right now. Roland makes some, but that's not the one I'm thinking of. Anyway, they make much higher end versions of that type of scanner, $30,000 versions of that type of scanner that you can go and scan very accurate geometry, and you can do that. But again, it's going to cost a lot. You could get a coordinate measuring machine. So this is kind of like this arm. It looks like a robotic arm, except you can move it around, and on the end of it is a stylus, and you can physically go and point to, let's see if I can find a picture of one. CMM measuring. Well, these are, let's see if I can find something more similar to what I'm thinking. These are more like here's what I'm thinking of. Like this arm, and on the end of it is a stylus, and every joint is tracked through some kind of encoder. And so basically the machine knows where the tip that you're moving around is located. And you can use that to touch off different points on this geometry and encode them digitally and create this point cloud. So you could do that. Again, you have to have a piece of special equipment. You have to have a CMM, which not everybody necessarily has one of those laying around. They're not, well, they range. They're not necessarily terribly expensive, but they can add up. And obviously the more sophisticated ones are even more expensive. Usually it's the software part of them that is the expensive part, is the software. So that's one thing you could do. And then there's photogrammetry. So, and there probably are some others. New iPhones have a LiDAR system in them. New iPads have a LiDAR. I assume more and more cameras will have LiDAR, which is it will do sort of like the Xbox scanner type approach. It'll do a similar thing. I don't have a new iPhone. I don't see it, but I do have an iPad that'll do this. And it gives you not details, but it gives you like room scale geometry. It could scan the couch back behind me and make a relatively decent representation of that, something that size. But it's not going to scan a tiny little object and give you details. There are laser scanners that will do that though, and they are kind of on the expensive range. Not terribly expensive, but they're probably not consumer level unless you really are trying to make money on it or you just have a whole bunch of money. Photogrammetry is basically free. Now, there are paid versions of this. It's mainly software. And assuming you have a way to take pictures, which most people have some way to take pictures. Now, the pictures you take do influence the final results. So better pictures will give you a better result. The one that I'll show you, I just took with my phone. So I just used my phone, which is an old phone. It's not even a new phone. But if I broke out the DSLR or something like that, then I would probably get better results. But you take pictures surrounding this object, all around it. So I didn't do that many. I took, I think, maybe 50 or something. Actually, let's see what I did. How many did I take? 80. In this one, I did it twice. So the first time I took 53 pictures of something, and it didn't work that well. This time I took 88 pictures, and it worked better, but also changed the object to be something that would be better to scan, or well, it's not scanning, to recreate. And we'll look at that in a second. There are a lot of software, like I said. The one that I used for this, and the one that I think is the most powerful free version, is called Meshroom. Let's look at it. This is Meshroom. It is a pretty, at the same time, super simple workflow, and then the more you want to tweak things, it has many layers to it. So there are many layers. So here are the pictures of this bowl I took. I just set it on a table. What it's going to do, what the software is going to do, it's not using like tracking information or anything like that. It doesn't actually know where the phone was when it took the picture, but it can piece together where the phone must have been based on all of the pictures. So it is kind of important that the thing you take pictures of has an even environment. So you don't take pictures in the morning and then go back in the afternoon and take pictures again, and then go back at night and take pictures again and try to put them all together, because all those pictures are going to be exposed differently. They're going to have different lighting conditions and shadows, and the software is not going to know what to do with those three different sets of pictures. You don't even really want to use different cameras. You want one kind of flat camera. Now mine, you can see here, the pictures are a little bit bright. It would probably be better if I took time to edit these photos and kind of flatten them a little bit, so they didn't have such high shiny spots and things. I literally just took the pictures, dropped them into here, and hit start. That's all I did for this geometry. And you can tell in the resulting geometry that it's not that great. Anyway, you got all of these pictures. These, you can see this little yellow shutter looking icon up here. That means that the picture's okay, but the metadata that's attached to it, so the time and date and the camera that took it and all that, this software doesn't recognize something about it. So it doesn't recognize this camera. Again, this is an older phone, and it's it might be that I could go into the software here and include more information in the metadata that would make these these little things would turn green. These little shutter icons would turn green. Actually, it might say what's missing. Let's see. Yeah, well, so it's the serial number metadata that's missing, and that doesn't matter. There it shows the important stuff it does know. It doesn't know the focal length. So it was estimated focal length, although it says focal length is 4.2, but I guess that's an estimated number. If I add my camera model from this phone into the sensor database of this software, then it would actually know the exact focal length and things like that, which would help the software figure out where the camera must have been when it took this picture. And so you can kind of see over here all these little, let's see if I can make them bigger, all these little camera icon things. That's where it is estimating each one of these 88 pictures was taken from. I don't know if it used all 88. Looks like it did. Well, there's a couple that are not being used. It used most of them. No, it looks like it used 86 of them. And so you can see where it's estimating. And this is roughly what I did. I put it on a table. You can kind of see the table here. And walked around it and took pictures of this bowl with these two artificial pears and these little leaves in it. And so you can kind of see all of the pictures I took walking around. And that's the idea, is that you walk around, take pictures. Now it is better if maybe you have a tripod or one of those steady, something that creates the most steady picture possible, so that there's not any blur or shake in the photo. And you can set, you know, even on a cell phone, you can set things like shutter speed and things like that sometimes, so that you have a non-blurry picture. And so you can kind of see here. Let's make these cameras small. So actually, let's just turn some of this stuff off. Turn those down so they're not in the way. So you can kind of see what it created. Now you can kind of see it's picking up other things every now and then, like the piece of a chair. Not sure what that is. Maybe another piece of a chair, but it has created all of these little dots that if I turn them off, you can kind of see the geometry that it's created. Now this looks really pretty good. You know, you got some craziness up here in the leaves, but thin things like the leaves in this picture are going to be hard to pick up anyway. But it looks like, hey, that's a decent job, but it's tricking you a little bit here. Because now, for one thing, let's see if I can find a good picture of the actual bowl. Here's one from the side. It is kind of lumpy and everything. It's not a very smooth surface to begin with. So that's one of the things I chose about this one, because it's not trying to recreate a perfectly flat surface. See the table? The tabletop here is flat, but it's created it as this, you know, kind of moon landscape looking thing. But if I turn off the texture and just look at the solid geometry, you can see what it actually looks like. So decent, but when you start to look underneath here, it's hard to move around in this thing. Start to look underneath here. There's a big hole here, but that's kind of to be expected, because if you think about where I took those pictures from, I didn't really take any pictures that would look underneath there to know what's going on underneath there. You can also see there's some holes in it every now and then. There's some holes right there. So again, I literally did no tweaking to any of this. I didn't do any post-processing or anything like that. This is just the geometry that I got. And so you can see that you can get relatively, you know, decent looking geometry. You could clean this up, take it into Mesh Mixer. I don't think we've talked about Mesh Mixer in this class. It's a good free piece of software. Now it is finicky. It crashes a lot, particularly if you're working on really large models, large size-wise, not physically large, but like a lot of megabytes, lots of points in them. It'll crash a lot, so you have to save often. But we could go in there and kind of chop off all this extra stuff. I'm not sure that this software actually comes with any post-processing stuff in it. I don't think it does. I think you have to go into another program. This is going to generate let's see what it generated. Well, that's the texture file. I don't remember where it put oh, maybe I can just, I think it saves it as a OBJ file. Let's see, here's the meshing stuff. So you could go in and change, yeah, there's OBJ, mesh.obj. The number of points that it's allowed to generate here. So right now it's at, is that 5 million? I think 5 million points. Those points are, let's see if I can look at the wireframe. So now you can start to see all of these tiny little triangles. Each one of those, each triangle has 3 points, and it shares those points with the triangles adjacent to it. So it's only limited to having 5 million of those points, which is a lot in general. And I don't know if I can change. I think maybe it just exports OBJ, which is fine. That's a relatively generic file format that you can open in lots of different. You can probably open OBJ directly in Cura. It would be pretty bad to open this directly in Cura just because it's not ready to print yet. It is very. I've gotten stuck in here. I don't know how to get out. Well, that's fine. We need to chop off the table around it. We could try doing that in Mesh Mixer, just so we can look at that, because we haven't looked at Mesh Mixer, and it is a pretty good piece of software. Let's see if we can get it. Again, it's an Autodesk product. It is free. Oops. There we go. Let's import. Is this it? I think that's it. Let's see. Well, yeah, it probably is. It's taking a long time to load the preview here. Wow. There, yeah, that's it. It's turned sideways, but that's it. All right. So it used 664,000 vertices or points. All right, so see, we got all this extra geometry that's not really part of what we want. And then in Mesh Mixer, make sure you can see this, yes. You've got this edit. There's a lot of different things you can edit. We could just cut, we could cut this off of there. We could, we'll maybe keep this side though. Cut that off. Let's try and get some of the excess stuff off of here. So what I'm doing here is I'm doing the plane cut, so it's going to create a two-dimensional plane, and then I'm just drawing across. You can go and like move the plane around. I was just drawing across there, and it's going to, in this case, it's going to discard the half I don't want, and keep the half I do want. You can have other options there, but I'm just doing get rid of it. See if we can get some more chopped off of here. So just kind of, see when it keeping this half I don't want, there's this blue arrow. Well, it doesn't get any larger. Blue arrow right here that you can flip which side it keeps. So you can kind of start to chop it down to what you want. It's in a weird orientation too. I'm gonna have to change the way it's twisted around here. But now that I've started this, I kind of want to get the mesh more or less the way I want it. All right, now it's kind of, see, it's weird, and it's hollow, right? So all these pictures were taken from the outside of the fruit bowl, and so on the inside it has just created hollow geometry. There is a make solid button here that we'll hit in a minute, but let's see if we can twist it around. So there's transform, and it gives you a little gimbal that you can use to eyeball it straight. That is much better than it was, so we'll go with that. And then now you can start to see, wow, it's pretty lumpy geometry. And then we still have some floating bits out here. We probably need to chop those off. I think we can select and might just be able to delete. Let me see. Oh, but I got some I don't want to cancel. Oh wait, select. I clicked sculpt. I don't want. You can actually go in there and sculpt. Let's see if we can just delete. Yep. So you can select and then circle parts that you don't want and hit the delete key, and it just erases those. So that's kind of handy. There are, let's see what else. Clear selection. That edit button also has make solid in there. So it's going to first go and estimate what it's got to do, and then it's going to give me some options on things that I might want to change. It might take a while because it is a pretty dense mesh. But you can't 3D print hollow models like this that are only one layer of triangles thick. It'll say that they're not manifold. Now, some slicers can figure out what to do with them anyway, but some slicers can't. I don't know if we put this non-hollow, non-manifold model into Cura, it probably would not like it. It might try to auto-repair it. I don't know. Wow, it's taken a long time to do this. It's probably also, since I'm streaming and doing this, and I still have Mesh Room open at the same time, that's probably bogging down my computer to where it's not going to do anything. This is also Mesh Mixer itself will get hung up sometimes. If I cancel, there's a good chance it's just going to crash. Let's see. Yeah. So when you're using Mesh Mixer, particularly with larger meshes, I didn't even look at the megabyte size of this file, but you should save often because there's a good chance you're going to lose work. Now, our work that we did was, hey, it came back. All right. It has a transparent preview for some reason. So when I'm making solid, I don't actually think I can do it now because it didn't. Well, we'll try. I want the accurate one, and then you can go in and kind of pick this mesh density and things like that. But if you do accurate, then it will try to preserve all of the surface features. Let's leave everything else the same and update, and I don't know, see if it'll do it. I'm not actually trying to make the model, so if it can't do it, it's not a big deal. In fact, I might let it run here and we'll come back to it later. In fact, let's do that. Let's go back to Mesh Room. Where did it go? Maybe I closed Mesh Room. This is the back end for Mesh Room. Okay, so how you use Mesh Room. Did I lose the window for it? I think I did. I think I lost Mesh Room's actual window. Let's restart Mesh Room. That one's not going anywhere. Yeah, all of Autodesk. I may have to close that down because I can't even move the window. Let's do some Task Manager. See if we can get it to close. Mesh Mixer in task. Let's see if it'll stop. All right, so we got that back. So that's one. Sometimes it crashes to the desktop. Sometimes it just hangs, and it's usually when you're doing larger files. So save often with those, and it's not all the time. It's because I've got like 5 different things going at once here. So I'm not going to be able to actually create a mesh live because it takes quite a while to do. But like in the 20-minute range, something like that, for it to process. And with other things running here, it might take an hour. Who knows? It might not process at all. But I'll show you the idea of what you do. So you open up Mesh Room, and then I had a folder. Let's see, where'd I put it? Here it is. So I have this little folder with all the pictures in it. So all the pictures are in there. And you just take that folder and you drop it over here, and it will go and figure out which one of the pictures, you know, assuming you only have one set of pictures in there, you probably wouldn't want to have like pictures of a fruit bowl and then pictures of another thing mixed together. It would not know what to do with that. So all the pictures series for one object go together. And then down here is your timeline of all the processes or the nodes that it's going to do. And this is the default one. So just taking all the default options the very first time is what I would recommend. And then you literally just push start. And it's going to say that, hey, do you want to save this? Otherwise, we're just going to put this in a temporary file that you might lose later on. So I usually do save it. I'm not going to actually let this run, so I'm going to continue without saving. And it will start. Well, now this one's already done. So, well, no, since I put it in a new folder, it doesn't know that it's done. But it went and got the database information from the camera. Now it's trying to go and look at all these pictures and extract features. and then it's going to go, match the cameras, match the features, try and build the structure, the geometry. It's going to, on and on and on. There's the actual mesh. It's going to do some cleanup, and there's the text. The texture is the colors and everything like that it puts on top of the mesh to make it look real. And so you can edit each one of these. Each one of these has a whole bunch of things. You can make parallel things. Maybe you want to do it more than once. You want to do, some iterative thing or whatever. All of these have the build. Well, I can't do it while it's running. Let's stop it, because it's going to literally take all of our class time to let this thing run, and it may not finish then. But you can duplicate, you can remove, add nodes, change the order. You can do a lot of customizing. The default set of things does a decent job, assuming your pictures themselves were good to start with. Now these are little like 2.5 megabyte pictures from a cell phone, and they probably could have been done better. I probably could get better results if I went in and tried to you can kind of see some blurry around the edges here, like if I had put it on a little tripod and moved that around and taken very clean pictures, made them a little flatter maybe, so that they don't have these shiny spots on them quite as much. But it did create the geometry similar to what I was looking for. So that's a way. It takes some time, but if you have an object that you don't have another way of getting the geometry, this is a way to do that. This is one of the optional assignments that you can do also. If you do decide to take this one on, don't think that you have to recreate the thing exactly. Just get close. Take your geometry into something like Mesh Mixer, and we might have to do a whole lesson on Mesh Mixer, because there's a lot of things in there that you can do, and so we might do that on something that's a little more manageable than this thing, or maybe we can get this to work. It's just going to be tough to stream it and process it at the same time. But Meshroom is free. There is a 2020 version that just came out, so this one might be slightly different from some of the tutorials you would see if you found one online, because it is relatively new. And a lot of the tutorials seem to be a little bit older than this version. I will say there's one issue with this one. Once you do start and let it run through the whole thing and it's finished, a lot of times there's supposed to be a load model button either over here or down here or even over in this area, and I've never gotten that to pop up, the load model button. And if you don't load the model, then all you have are those little points that it has tried to create. So to make it load the model, just double click on this texturing box. So if you double click this, that will also load the model. When it doesn't, at least mine has never actually shown the load model button that's supposed to be in one of these spots. But if you double click texturing, it'll load the model. Seems like that always works. And that's what gives you the actual solid geometry that you want to look at and see what you actually got from your scans. Or they're not scans, from your pictures that have been recreated into a three-dimensional object. And try to take a lot of pictures. 88 even isn't that many pictures. Try to make them all sharp and all under the same lighting conditions. Like when you're taking the picture, don't lean over and get your shadow in the picture sometimes and then your shadow's not there other times. That'll confuse the algorithm. Don't move anything in the background. So like in this picture, you can kind of see there's this rolled up mat in the background. It needs to be in the background of every picture then. I don't need to move it here and then move it off the table. That will confuse this picture. Like in some of the pictures, there's this black tube in the background, and others there's not. So make sure that you don't change the background, at least not significantly, because it will confuse the algorithm on sometimes there's things in the background and sometimes there aren't things in the background. Also, you might think, hey, I'll just put this thing on a turntable and take a bunch of pictures. This type of software doesn't work well that way. There are some processes where that's what you do, but those are more of the scanning type things where you're shooting a laser beam or infrared beam at it and let it bounce back. But the ones where you're trying to reconstruct from photos, you need to move the camera around the object. Don't move the object, because then you're going to create this weird shadows that aren't the same in every picture. That looks like the sun's changing directions, all this kind of stuff. And the software is not going to be able to figure out where all of these pictures came from, because it's looking for shadows and objects in the pictures and it's trying to match them up from picture to picture. So if they're moving, then it's not going to be able to figure it out. So move the camera, not the object, for this kind of process. Okay, let's close this down. Let's see. Let me look in chat. Okay, nothing, no questions there. If you have some questions, I'll answer them the best I can. Again, I'm not a real expert with this. I have used it before and I've created some relatively cool things. One thing to be aware of, though, is that unless you spend a lot of time later, like after you get the geometry, it's probably going to be kind of rough. So it's going to be bumpy and things like that. You can go into programs like Mesh Mixer and smooth out surfaces. Generally, though, that's going to lose any... it's going to lose fine detail. You're not going to get fine detail very much to begin with. You can kind of see what level of detail I got with these pictures. But smoothing it kind of loses the dimensional accuracy, if there ever was any. I didn't even bother to measure, if this thing was dimensionally accurate at all. You could scale it to where probably it was close enough for what you were trying to do, but don't think you're gonna take some pictures of a little tiny thing and get a lot of detail out of it. This bowl in real life. Well, those are pears. They're fake pears, but they're pear-sized things. So you can kind of get an idea how big this is in real life. And I probably wouldn't try to do something any smaller than that. You could do it, just to keep adding pictures, if you want to create something similar. All right, I'm going to close this down. I'm going to discard any changes. Shut that off. All right, what else were we going to do? We were going to look at this Wood PLA. Oh, well, this guy's here. I painted some on this guy, so you can kind of see. This is the one that we resin printed. Now, he's a little shiny right now because he's got a varnish that I haven't dull coated, but they come out pretty good. Just resin print. So he was sitting there. Let's move him out of the way. All right, so the Wood PLA. I used this, which the prints are actually really good. It was really simple to print with regular speed, higher temperature. I printed at 210. I changed the retraction settings slightly, but it actually printed really easily. And here are some of the things I printed with it. So printed this, and this is at a 0.15-ish. I don't remember exactly what I had, but somewhere in that range, layer height, so pretty thin layer height. And I will say that it is really tough to see. Now, these are thin layers, but it's really tough to see the layer lines. I don't know if I can even get close enough to where you could begin to see what the surface looks like or not, but there's not really any layer lines. Now, I think, so this is supposed to be rosewood. It's 30% rosewood, 70% the PLA mix. I don't know that this is the best color, because you kind of lose this darker rosewood color. It does look like rosewood. Like, I have some guitars with rosewood fretboards, and this is what they look like. You don't get a lot of the striations or wood grain or anything like that, but the color seems about right. But then I tried, well, can you do things like stain it or anything like that? And I couldn't get a good, I didn't have that many stains to choose from here without going and getting some. But the ones I tried didn't really make any difference. They made it glossy because they had a polyurethane mixed in. But that was about it. So I think if you're trying to get a really good wood coloring, it might be better to do one of the lighter wood colors and then stain that to look like the wood you want it to look like. This does look pretty good. it's a little bit, now part of the shininess is the, you know, the faceted nature of the model itself, but I don't know if I would be totally convinced that this was carved from wood because it is a little too shiny. I might try spraying a dull coat on it and see what that does to it, or maybe I'll try some other things to see what it does. But when you print these thinner layers, then they kind of disappear. This one is 0.2. This is that card holder thing again. That was what we tried to paint to look like wood, and it just didn't work right. Focus on this. And 0.2 also kind of disappears the layers, except for the top. You can certainly tell that the top is 3D printed. At least it doesn't look wooden-like. But the sides, you can't really see the layers. Bottom also looks 3D printed. And this is at 0.2. Once you start getting larger layers, let's see if I can find one. This is one that I half put some of the polyurethane stain on it and half didn't. This one's 0.3 something layer heights, and you can definitely start to see the layer lines. Once you get to that thickness, at this point it's kind of just brown filament. It doesn't really have much woodness to it because the layer lines are so strong, but it does. I did do some other things. So one of the things that I've tried out is it does have 30% wood. It's not sawdust, but they're wood shaving. I don't know how small they are. The small wood particles in there. So you can sand it. So I did try some sanding, and you can still see and feel. This is a thicker layer line too. This one is this is in the 0.28, I believe is what I printed this one at. And so you can see the layer lines. They're not as bad as the one here. These are pretty thick, but they're visible. But it does sand better and easier than regular PLA. So I will say that it does sand much better. I didn't sand a lot. It is pretty smooth though, and if I sanded on it more, I think I could get this down to where it looked like a block of wood, and I might try that. So I haven't finished doing that. I just sanded some just to see. I did another one like, well, if sanding works, do other wood things work, like scraping and planing? So I tried that. The planing does work, but so this part is planed, but it has a tendency to pull an entire layer off. Like, see, it pulled this entire outside perimeter off of here, and up there it pulled it off. But I wasn't using a particularly sharp plane. I didn't want to use something nice on a piece of plastic, so it was not that great of a plane to begin with. But it kind of worked. But then I thought, well, scraping might work, and I didn't have an actual scraper, so I used a thing kind of like a scraper and scraped. Let's see, I did this side, and it actually works pretty. Oh, I was going to show you. Here's some of the when I was planing. You know, it does make sort of like. I mean, they're a little thick. You can see, and so maybe if I spent some more time adjusting the plane, I could get the plane to work without ripping the walls apart. So it does sort of plane. Scraping actually works pretty well. And I think if I had an actual scraper instead of what I was using, that it would probably work decently well. And it's fast. It's faster than sanding for sure. And here where I scraped it, the layer lines are pretty much gone. I didn't scrape this side. Well, I hit it a couple of times, but right in there, it's actually pretty much gone. And these were thicker layer lines. Well, you can't really tell. It's so hard to get it to focus where I want it to. Focus on that. Maybe it doesn't focus very closely. Well, trust me that these are pretty thick layer lines. And scraping worked pretty well. I tried ironing on the top. And what ironing is an option in your slicer where the hot nozzle will basically go back over the print on a flat surface and iron it. So the idea is that it irons it smooth. I didn't have enough top layers on here. I only did 2 top layers. I was trying to print these relatively quickly, and the ironing warped the top layer, so it didn't look very good. I might try it again with more top layers, but it warped it. You can kind of see all these low spots and high spots. Then I went back and sanded it just to see if it would sand. It did sand easily, but the ironing didn't work too well. Certainly not with two top layers. Need more than that. One thing that was recommended for printing wood filament is that it clogs really easily. So they said you should print with a larger diameter nozzle. So the 0.4 diameter nozzle that was normally in our machine, I traded it out for a 0.6 for one of these. So 0.6 millimeter nozzle. And so all of this was printed with a 0.6 millimeter nozzle. Even the 0.15 layer height print was printed with that. And I had no clogging issues at all. Like I said, I printed it a little hot at 210, but that was right in the range of what the box said to do for this filament. One problem I did have, so I printed this guy this size. Where is he at? This size. And then I printed it this size. And this one uses a 0.45. Since I have a bigger nozzle, now I can do bigger layers. So this one is 0.45 layer height, and you can easily see the layer lines. I don't know if you can see them on camera or not. Actually, on camera, it looks pretty decently like wood. The problem with going this thick, though, is the layers are delaminating. So right here, you kind of see it's really, and this is spiral vase, so it would just spiral all the way, you know, and completely turn into a slinky. So when you're doing these thicker layers, one thing you need to do is you're dumping out a lot of filament when you're doing a thick layer like that, and there's a good chance that your nozzle temperature is dropping because you're pumping out so much filament. And so I probably should print this a little bit hotter than 210 if I'm going to try and do the thicker layer lines, because it just doesn't have any layer adhesion. It came out, it was fine, and then when I went to move it off the bed, the bottom broke off, and then I was like, well, this is pretty weak. How weak is it? And I did a little bit of, you know, squeezing, and you can hear it popping every now and then. This one is, I can squeeze this one pretty hard. I'm sure I could crush it if I really wanted to, but just normal handling is not going to accidentally crush this one. But this was the much thinner layer lines. Oh, by the way, this one, the small one, took longer to print than this one. This one took an hour and a half to print. This one took 2 hours to print. So, and I kind of like the thick layers. It doesn't necessarily give a great wood effect or anything, but being able to print at size really quickly is kind of nice. Now this is also spiral vase mode, so it's only printing one outer perimeter. So it is, you know, it's going to be weaker anyway. But I might try this one again with a hotter temperature and let you know if it sticks better, or if it does this again. So what I had to do to change the nozzle out, if you want to change your nozzle, and there's a couple of reasons you might want to change your nozzle. One of them is you want to go to a smaller or bigger nozzle. Maybe you want to print, you know, tiny little guys, and you don't have a resin printer, so you can do this kind of thing on these Ender printers if you drop down a size in your nozzle. Or maybe you want to print some big stuff and you want to use really thick layer lines. You want to go up, so go up to a 0.6. I even have a 0.8 somewhere that I'll try putting in there to make some really thick layer lines. Or maybe you want to change over to a non-brass nozzle, so you want a hardened steel nozzle or something like that. So there's several reasons you might change a nozzle, and they're cheap. Well, so the hardened steel nozzles are more expensive. This 2-pack, I think it was, I don't know, $8 or something. So it's not like prohibitively expensive, but the brass nozzles are $1 each or less. And then they actually make nozzles $100 for a nozzle. but that one's got a ruby inside of it where it's basically never going to wear out. You might not necessarily be trying to print high temperature stuff, but glow in the dark filament or copper fill. So the same thing as wood, except instead of wood particles, it has copper particles, or something like that. Those are going to be really abrasive to a brass nozzle and basically eat it alive. And you might not even be able to finish the print with some of those copper fills and stainless steel fills and stuff like that. So you're going to need a hardened steel nozzle to print that kind of stuff. Even the glow in the dark is abrasive enough to chew up a brass nozzle. So to change the nozzle, let's look over here. I got to lower the thing. It was way up at, oh, well, that does remind me of one thing before we get too far, the light bar. So, oh wow, I can't even get to it. Where's it at? It's up here. The light bar that we put up here. I really like it. It does create one tiny issue on the really tall prints in that you're going to lose a little bit of your printing height because it overhangs the front here. It overhangs the front, and so all of this is going to crash into that where normally it could go above there. You can still print really tall objects, so I don't think it's that big of a problem, but it's something to be aware of. Let's take this apart so you can see inside here. If I can find my tools. They're always missing. They're not missing, they're just hidden with all the other junk. Alright, so see if we can get this off of here. You don't necessarily have to take all of this off to change the nozzle. In fact, you may not want to at first, but this is just so we can see things better. All right. If you are doing this while it's running, this front fan is going to be running also right here. So be careful that you don't poke something in there accidentally, poke in there, or set this on something where anything can get in those fan blades, because they're pretty brittle and they'll snap off of there in a hurry. So let's get it out of the way, get that out of the way. All right, so most of these have a little silicone sock on them, and you would think like, oh, okay, now I just unscrew it. Well, there's a couple of things you need to know first. One is unload the filament. If you try taking it apart with the filament in there, then it's probably gonna not be as easy to get the new nozzle back in, because there's gonna be filament in the way and everything. It's gonna the filament in here, when this is cool, has solidified to this shape, and so it's gonna be in the way, and then it's just going to make a big mess. So heat it up, pull the filament out, and I would not take the nozzle out while it's cool. Even though it's going to be hot, I would heat this block up in order to get the nozzle out. It's heat cycled a couple of times, and well, the one from the factory is going to have been put in that way to begin with. They're going to have heated it up, put it in, and heated everything up and tightened it down, and so that metal has expanded and contracted several times. And so heat the block up. Maybe you don't have to heat it all the way to printing temperature, but you need to be close to printing temperature. Get some sort of way to hold the heater block. So I used adjustable end wrench, and then get a tool. Let's get that off there. Get a tool that's going to fit the nozzle. So I have these tiny little wrenches that the nozzle I took out was a different size fitting than the one that went back in, so I had to get 2 wrenches. But get one that fits pretty exactly, and it's heated up. You're holding a back up on the heater block, and then you undo it. And it will all be hot, but once you break it loose, you can let it cool down and then finish taking it out. So that's the order. Remove the filament, heat it up, hold the block with a tool of some sort. If you don't hold the block, there's a really good chance that you're going to shear the little throat inside here, the heat break. In fact, why don't we take this apart? Take it apart. Well, if I do that, let me heat it up and take the filament out so that we can see. I like how the light, it lights up everything. It's not that great. Oh, the BO Touch failed because it was turning sideways, but that's okay. I'm gonna heat this up to some temperature that I can get the filament out with. That should work. So this is going to, you have to remember that this is going to be hot. So we'll let that heat up a little bit. I think I'm going to go ahead and take this off because I was going through our upgrades that we haven't installed yet, and I remembered that we have a Titan Aqua, and I think we'll try putting that on here. It's overkill for this little thing, but it's a water-cooled hot end, just so you can see the process of change if you're interested in changing all this stuff out. I would put it on the Tornado back here, but it already has a Hermera hot end on it, and so I don't want to change that one out. It's pretty good. Let's see. We're not quite warm enough to pull the filament out yet. I think we are now, though. All right, so get our filament out. Yeah, there it goes. Have to get that out of the way. I will say that this wood filament was the easiest filament I've ever, or easiest wood filament I've ever used. So I might get some more of that brand, but a lighter color to see if I can get more wood type filament. We'll see. All right, so here's what I would do. There we go. And now the nozzle's really hot. You could go ahead and start it cooling down. And sometimes you have to do this to get a clog out. One good thing about these particular ones, if you take this nozzle off, you can push the tube all the way through and just purge everything out of there if you really want to. There went the nozzle. So there's the one that we had in there, and you can see, I don't know how hot it is. Pretty hot still. Let's see. I can pick it up with these. You can see they're going to be clogged with filament. So if you don't get all that filament out of there, then it's going to be in your way later on. So I'll have to, if you do this, something like this, you can use a heat gun or something like that to remelt this filament and pull it out of there. You have some tweezers or whatever. You can put it back in there and not get this everywhere. Let's see, is this still pretty hot? While we're here, let's look at our different pieces of our hot end. So we saw our nozzle. It was on the bottom here. So this guy is the heat block. These two big wires here, these are going to a cartridge heater. You can kind of, yeah, you can see the end of it right there. And that's what's actually heating up the heater block. It's just a big resistor. Usually they're like 18 ohm resistor, I think. No, 18 watt heater. Maybe that's it. And like a 1 ohm resistor. I don't remember. Off to the side, you can't really see them in that picture. Well, you can see these white-ish coated wires back here. Those are going to the thermistor. It's next to the heat block, really close to the nozzle. And it is measuring the temperature. So whenever you get your temperature readout on your screen or whatever, it's coming from that thermistor. Right here, let's see if we can get down closer to that. Yeah, you can see it there. So right there, that's the heat break between our heat sink and our heat block. So down here we want molten filament. Up here we want solid filament. And this little heat break between the two is making sure that those two stay solid and molten on the right side. If you get molten filament up here, which is what can happen if this fan fails or is off or something like that, then you're not going to be able to push new filament out, and that's when you're going to get clogs. So a lot of times the clogs come because something happened to this fan, or something is wrong in the way you assembled this hot end. So if you took the hot end apart, there's a good chance that you did something that moved this heat break too close to, well, the hot heat block too close to the heat sink. There should be an air gap between these two. This little heat break is just a tube with threads on the end of it that's connecting these two pieces. Now this one actually has a set screw, so there may not be threads on the top part, but there's threads in the bottom part at least. We'll have to take it apart once it's cooler to see all of the pieces of it. But if this is too close, then you'll get radiation. You could even get conduction between the hot and cold sides of your hot end, and that is always going to be bad. So when I was using this backup wrench, it was to prevent this little heat break from twisting and shearing. Now this one does have screws here and here to kind of help prevent that also, because I assume there's probably a lot of people that just, get their wrench out and start twisting on the nozzle without heating it up, without holding a backup. So it might be okay to do without holding a backup on here, but I would be afraid that this would shear or twist or something is not what you want to do. Still kind of hot, so we'll wait a minute. So those are really the only parts. There's a nozzle, a heat block, heat break, and a heat sink. And then you've got the the other pieces like your little quick connect, you've got your heater and your thermistor. So we're going to change out, not today, but I saw on our Moodle page that high temperature printing is a couple of days away, and that is when we're going to try. I've never actually used one of these Titan Aqua hot ends, so we're going to try putting that in here so we can do high temperature. It's supposed to go up to like, I don't know, 300 degrees Celsius, so we can print a lot of different things that we normally don't print. The issue with those higher temperature printing is usually they need to be enclosed somehow, so we might have to figure something out for that. What other things do I have here? Oh, a couple of other things I found. While we're at it, we're going to get this out of the way. I'm going to put some Capricorn tubing. So this is replacing the Bowden tube. Now, the Titan is a direct drive, so it won't need this. What this does is it replaces this tube, and the advantage is two things mainly. One is you've got a thicker wall on your tubing, so it's stiffer, and you're supposed to have a more accurately sized inner diameter, so that there's very little room for your filament to slosh around inside the tube. So that's going to help particularly with retractions. When you're pulling the filament out and back in, there's not a lot of slop between the filament and the tube. It also helps with feeding accurately and all of that kind of things. But when you're doing a lot of retractions or high retraction rates or speeds, then that it will help with that. So that's Capricorn tubing. One thing if you ever do change, even if you just pull this out and need to replace that last end because it's worn, over time this end that's in the heat sink will get worn. You don't have to use one of these things, but they're so cheap that you probably should use one of these. So this is just a little guillotine cutter, because one way you're going to get clogs is if this end is not square. When you put it down in here and there's a gap, that gap will get filled with molten filament, and you're going to get clogs. So be sure you can print things like this. It's just a razor blade and a a fixture, but be sure that you have carefully cut the end of your Bowden tube square with the tube itself. Most of the time, if you buy Capricorn tubing, this is going to come in the packet also. Found these. These are solid connectors for the Z motor. I haven't installed these, but all these do is most of the time your Z axis is on a connector that is flexible. I don't know if I can get down there to it or not. Yeah, right there. So you can kind of see, now this one only has one little gap between it anyway, but they have a little bit of flex to them, and so that allows in case there's any misalignment. So I would rather have my printer really well aligned and use solid fixtures. Remember, we already changed out, instead of springs, we have solid supports here. So the more things you can remove that flex, the better you're going to have printing later on, and you'll be able to print at just slightly higher speeds. Now the Z-axis is never going to move fast. It's going to be pretty slow. It's moving 0.2 millimeters at a time. But if it wobbles back and forth, if the Z rod back, well, I'm pointing to something you can't see, but the Z screw on the back, the lead screw, if it's wobbling back and forth, then there's this little bit of motion here, and it will show up in your prints as these sort of like waves or ridges in your print. If you ever see ridges in the side of your print, check and see if the pattern of those matches the screw back here, matches this screw. If this screw matches that pattern, then that's what's happening. Your wobble in that Z axis is showing up in your actual print, and so it's moving slightly back and forth. So I haven't seen that in this printer anyway, but we're going to replace that with a solid mount instead of a flexible coupler. And then we're going to put the water cooling stuff on here. We might totally break the printer, but we can always put it back to the way it is now, and see what's going on with that. All right, what else did I put in here? We did nozzles, we did wood PLA, we did the photogrammetry. I think that's the main things. Next week, we're going to look a little more. We already looked a little bit, but we're going to look some more at the duet board, maybe actually get in there to see what it looks like. I showed you a picture of it, but not the actual board here. Hopefully run it and show you, some of the advantages. We already talked a little bit about it, but we'll talk about it some more. And then we've got topology optimization. So this is more of a modeling technique where there are two styles of it. So one style where you create multiple hard points and create geometry between them. Another one where you create a model and identify some hard points and then subtract away until you get the minimum, most optimized shape between those. And so those are the two different processes. One by Fusion 360 does the additive version, and SolidWorks does the subtractive version in general. Or is that the other way around? Maybe it's the other way around. I have to look at it. One of them does one way and one does the other, and don't remember which is which now. But we'll look at those. They're pretty neat. That's also one of the optional assignments where you can create a computer optimized part to 3D print. All right. I'm going to go jump over to Zoom in case anybody has any questions. I did start grading some of the benches, so you might start seeing grades show up on those now. I haven't finished the ones that were uploaded yet, but I did get, I don't know, maybe halfway through with them. So I'll work on those some more today. And I will see y'all next week.